Saxon Algebra 1/2 with an escaping book. Lesson 102, adding more like terms. We're going to be adding like terms for a long time, you guys, so we might as well get really good at it, right? Remember that the basic idea with adding like terms, we have a variable, which is a letter, and we have oftentimes what's called a numeric coefficient. That's fancy math talk. That just means number, okay? So I often just say number and letter because there's no reason to make this harder than it needs to be. Sometimes we also have an exponent, okay? That's associated with the letter. Now, in order to be like terms, the letter and the exponent must match. Okay? So the numbers can be different, but the letter and the exponent has to be the same. Once we determine that they are the same, then we can add or subtract them. And remember, adding a negative number is the same as subtracting. So those two words have sort of, adding and subtracting kind of mean the same thing now. Okay? This will be the rule. This combinations of things can get messier and messier looking, but we can still do it. So let's try an example and see what the trick looks like to these. Are 2xy squared and 3y squared x and 7, sorry, I shouldn't be talking. We've got three different terms here. We don't want to add them. John's just asking, are they like terms? So, okay, the letters and the exponents have to match. Okay, this is 2xy squared. At first glance, they look really messy, don't they? Now, here's another super important hint I'm going to give you. When we're comparing terms to see if they are quote unquote like terms, it helps if we put each term into alphabetical order, ABC order, it's faster to write. Because then everything's neat and tidy and it's easier to compare. This one's perfect, right? X, Y, Z, that's the right order. This one's out of order. It looks like something different, but when we rewrite it, carefully making sure we put the exponent on the proper letter, we see, oh, this is the same thing, it's just in a different order. Okay, so those are the same. Now let's look at the 7. The 7 doesn't have any exponents, but it's got two y's. So I'm going to write the 7, then the x, because that comes alphabetically next, then the y, and then I'm going to smush those two y's together to make it y squared. Hard time talking. Now we can see that after we straighten things up, we have the same letters and exponents matching. So yes, these are like terms. Yay! I mean, it's not bad if they're not, but that's the right answer. Okay? And that means we're allowed to add them, and that's what we're going to add to this process. In the next problem, ready? Simplify by adding like terms. Here comes a long stream. This is 102.2. There are a total of 3 examples in this lesson. Okay, do yourself the favor of putting plenty of room around these terms because you need to look at them carefully. Now, I copied it just as it was in the book, but remember about the ABC order. You can fix that as you're copying the problem out of the book. I would have flipped that, but I want to show you exactly what's in the book. All right, so I'm going to rewrite this one. I'm just going to cross it out. I don't want to write the whole thing over again. Here, I'm going to double check it and give you a better chance to copy. Okay, that's correct. So what I like to do is find the most complicated term first and deal with that. If there's a square, I want to deal with that. I don't see any squares. This is not a 3. That's just a regular 3 that I didn't write properly. I think this XY term is the craziest. So I'm going to double underline those so that I can make sure I'm noting that the letters and the exponents, of which there are none, but that's okay, they match, right? So now I can combine those and I get 5xy. That's the first part of my answer. Now I'm going to go do the x's. I'm going to put a wiggly line under them. Notice how I'm using markings to help me zoom in and identify the ones that I'm looking at that go together, right? These x's go together, and that's going to be plus 10x. And then I'll put a square around these. 3 plus 4 plus 2 is 7, 8, 9. And yes. Now, John does something that I don't like. He writes his answer like this: 9 plus 10x plus 5xy. You'll notice that each term is the same as mine, right? We got the same answer. The order doesn't matter because in adding, order does not matter, right? 2 plus 1 equals 3, just the same as 1 plus 2. But very often in algebra, we want to arrange things from most complicated to least complicated, and I like to start training you in that right away. This does not satisfy that need. And if we just throw things down in any order, we're going to regret it later because we're going to have to break the habit. So put them from most complicated to least complicated whenever you work these problems. Here comes another one. Ready? I'm going to write it down exactly as it is in the book, and then I'll tell you what I would do differently if I were doing this as my homework. Double checking. Okay, what I would have written differently is this one. Because when we have two of the same letter, we don't usually write the letters like that. We write it as squared. So I would rewrite this term as 2x squared. If I was a student, I would not have even written this down on my paper. I would have automatically switched it to that. 2x squared means the very same thing as 2xx. This is a less sophisticated way to present it. We choose this presentation. Okay, so now I'm looking at all my terms, and I'm looking for things that match, letters and exponents that match. The numbers don't have to match. We don't care about that, but the letters and the exponents must. So here I see an x squared, and here I see an x squared. So I choose to double underline those. I can choose any different pattern, but it really helps to use the patterns. But this time I'm going to do something different. I'll show you in just a second. Positive 3, positive 2, that gives me 5x squared. This time, I happen to have some different colored markers sitting by. And so I'm going to show you that, okay, the next term is the x term, right? It works out really nicely to use a different color pen. It just helps the different terms pop out at you. And then the plain numbers. So this is a fun way to throw a little color into your lesson, make it a little bit easier to see the different things that you're adding. Notice I achieved the same effect, but just by using different patterns, right? Doubles and squiggles and boxes, and you can do all kinds of different patterns to show which terms you're combining. But I do recommend that you do either color or the different shapes so that you can clearly see, oh yeah, these are the like terms, so I want to combine them. Again, John gets the same terms as us, but he gets them in a different order. I don't like that. Put them in order from most complicated to least complicated. Right? The more letters, the more complicated it is the general rule of thumb. Okay, that's the end of lesson 102. Yay, goodbye.